Welcome to Geometry. This is section 1-4, measuring angles. The essential question is, what is the precise definition of an angle? How can you name it? And let's begin. So angles. Angle is something that's formed by two rays with the same endpoint. So here's an example of an angle. I can call this angle angle A because A is the vertex. I can call it angle BAC because BAC, using a point from each ray, and A is the vertex in the middle. I can also call this angle 1 because I've labeled this angle 1 right in here. Another way I could do this, well, if I got BAC, I can take the reverse and call this angle CAB. Rays are the sides of these angles. So we got two rays in this case. We got ray AB, and then we got ray AC. The vertex is the point, the endpoint of both rays. In this case, we have a vertex A. All right, let's move on. Exterior and interior. So these are two areas of an angle. Interior is inside, exterior is outside. Pretty straightforward. Moving on. We can measure the size of an angle using degrees. So I'm going to use a protractor here. I pull out my protractor, and we're going to measure using this protractor. What you want to do, you see this, there's a point in the middle right here. Usually it'll be a little hole so you can put your pencil through it if you have a real protractor. I'm going to put that right on the vertex. Best as I can. I'm going to put it, let's call the vertex right there. And I got to measure this angle. Well, that measurement of this angle is going to be this outside area right here. Look at that. So that angle is right there. And what's the measurement of that angle? Well, you have two sets of numbers on here. You always start at 0 and you're counting up. So this is 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50, 60. It looks right above 60. I'm going to call that 62 degrees. Make sure you have the degree symbol. So the measure of angle A is 62. You need this lowercase m to say measurement. And we say equals because we're not talking about figures, we're just talking about a value. Measurement and a degree is a value, so it's equal sign. Alright, this is protractor postulate. What does this mean? There's a lot of words up here. But basically you have two rays and they form an angle, and this angle is going to be, you can represent that from a number between 0 and 180 degrees. So we can measure it using a protractor. Here's how that works. Say if I have these two and I want to measure it. Two ways I can do this. I'm going to pull out my protractor again. And I'm going to put the vertex O, we're going to put that right there. And the measure of this angle right here, going from that spot to this spot, well, it's kind of hard to see right there, but you can just take the difference of these 2 degrees here. The degree of this point A, the ray OA, looks like that's about 120 degrees. So I'm going to say that's 120. And then I'm going to subtract right here, and it looks like for BOB, it looks like it's about 62. So 120 minus 62 is going to be 58 degrees. That's the measurement of OAB. Another way I could have done that is rotate this protractor. So one of the rays is the base of the protractor, and we see how many degrees this goes up. And it looks like that's just under 60. Yeah, that's 58. So 58 is my answer. You'll play around with that more. You'll get used to it. Different types of angles here. So these are just labels we have for angles. You want to write this down and get to know these. Let's see. The first one. Get out of my way. So the first one is going to be an acute angle. Acute angles are angles less than 90 degrees. They're tinier. The right angles are 90 degrees. And you'll usually see this little box in the corner. Whenever you see this box, that means there's a right angle and it's 90 degrees. Obtuse angles are bigger than 90 degrees. So they're between 90 and 180 degrees. But you don't go all the way to 180 because that's a straight angle. Straight angles are just a line. Straight across. 180 degrees. Moving on. So congruent angles. Angles with the same measure. The definition, the way to say this is if the measure of angle A equals the measure of angle B, then angle A is congruent to angle B. We can also flip this around too. So I could say the measure angle A is congruent to, if angle A is congruent to angle B, then the measure of angle A equals the measure of angle B. Notice we're talking about measurements. This is a value. We're using the equal sign. We're talking about figures. We're still using the congruent sign. Moving on. So another way to mark congruent angles is just to put these arcs on them. This, instead of saying, well, this writing this out and saying this angle is congruent to this angle, or this angle is 58 degrees and this one's 58 degrees, we can just put these arcs. So when they have the same number of arcs, that means, so same number, that means they're congruent. That is congruent. So in this case, the top two have one arc each, 1 and 1, so those are congruent. In this one, there's 2 arcs each, so those are congruent. Just an easy way to label that. Last thing, this postulate, the angle addition postulate. What does this mean? It means if we got 2 adjacent angles, they can be added up and they equal the whole thing. It's just like the line segment. The 2 little chunks add up to the whole thing. The little chunks, the measurement of AOB plus the measurement of BOC, adds up to the whole thing, AOC. Let's try this out. So here's some examples. Pause the video. Alright, let's try this. What are 2 other names for angle 1? Angle 1 is right here. So another name, let's see, we can always use JMK, because that's the angle right here, JMK, so angle JMK. Another way, we can always flip that and go KMJ. Now, you might say, well, can we just do angle M? Because like that first example, we had just angle A. But that only works when there's only one possible angle for that vertex. In this case, we have angle 1 and 2. If we just try to say angle M, are we talking about this angle, angle 1? Are we talking about angle 2 or the whole thing? We don't know. It's too ambiguous. So we can't just say angle M. Only 2 options right now with what we know are angle JMK and KMJ. Try this example. Pause the video. Alright, let's begin. If the measure of angle RQT equals 155, what are the measure of angle RQS and measure of angle TQS? This goes back to the angle addition postulate here. The whole angle is RQT. So we can make an equation. 155 equals the 2 chunks. So we're going to set an equation, solve for x, and we'll be able to fill in our numbers. So 155 equals 4x minus 20 plus 3x plus 14. Alright, solving for x, first thing I'm going to do is combine like terms. Combine 4x and 3x. That combines to 7x. If I combine negative 20 and positive 14, combines to negative 6 equals 155. Next step is I'm going to add 6 to both sides. So I get 161 equals 7x. Last step is to divide by 7. And when you divide 161 by 7, you get 23. So x equals 23. But I'm not done, because I've got to find the measure of RQS. So I'm going to find the measure of RQS. I'm going to do that over here. Of angle RQS. Well, I'm just plugging in 23 for the x, so it's 4 times 23 minus 20. 4 times 23 is 1, carry a 2, 92 minus 20. So that's going to be 72 degrees. 72 degrees. Measure of angle TQS. So that's going to be 3 times x, so 3 times 23, plus 14. 3 times 23 is going to be 69 plus 14. Add up, 9 plus 4 is 7. Wait, no. 3, carry a 1. It's going to be 83 degrees. So that's my answer. 83. That's it.